Display of exercise 1 of set 10 in MA301 game theory. We start with a 3x3 game. We're given the payoff matrices and we're asked to draw the best response diagrams, identify the equilibrium, and then write down the Lemke-Hausen path that starts at 0, 0 for each missing label and find the equilibria that can be found. Let's start with a bit of theory. The first step of the construction is the unique numbering of the pure strategies of players to identify them more easily. We start with player 1 starting from 1 to m, and for player 2 we start from m plus 1 to m plus n. So in our case we have strategies 1 to 3 for player 1 and 4 to 6 for player 2. We then proceed to the second step, the geometric representation of the sets of mixed strategies. So we name the strategies of player 2 as y1, y2, y3, and identify three axes, y4, y5, y6. Apologies, strategies for player 2 were 4, 5, and 6. Therefore, we have axes y4, y5, and y6. The triangle is the triangle of all possible mixed strategies, where the coordinates, the three-dimensional coordinates of each point on the triangle would give us a mixed strategy of player 2. So, for example, the point in the middle, or roughly in the middle of the triangle, would have coordinates 3 over 10, 3 over 10, and 4 over 10. The third step, and the most important one, is the construction. In the construction is the subdivision of strategies into best response regions. That is, we would like to know which strategy is the best response to the strategy of the other player, which area of the triangle would constitute the best response to each strategy of the other player. So, assuming that player 1 has got would choose strategy 1, the payoff would be for player 1 0 times y4 plus 3 times y5 plus 0 times y6, and so on for strategy 2 and strategy 3. So the strategies give us possible responses, and then we would have the expected payoffs. So, question is, when is player 1 a best response to the strategy of player 2? So, when is payoff 1 greater or equal to payoff of strategy 2 and greater or equal to strategy of to the payoff of strategy 3? Using the equations, we would have that the first condition is satisfied when 3y5 is greater or equal to y4 plus y6, and the second condition is satisfied when 3y5 is greater or equal to minus 3y4 plus 4y5 plus 5y6. We can